Okay, so let's just go through a revision what we have done so far in the nodal analysis. Okay, first of all, we are not learning nodal analysis because we love to acquire extra knowledge. No, that's not the reason. We are learning nodal because it is more efficient technique, and we have seen that it can reduce significantly the number of needed equations to solve the same problem if we use the classical KCL and KVL. Then the question is why we are learning KCL and KVL, because these are the most fundamental techniques in any circuit analysis, so you have to learn them. But we already eliminated other circuit techniques like mesh analysis, Thevenin, Norton, superposition. So there were in the past some other techniques taught to civil engineers. In my opinion, they are not needed. These are what I consider as extra knowledge, which is not really very important for civil engineers. We're trying to learn the techniques that are more efficient and fundamental for us. Okay, so let's see the nodal analysis, what we have learned so far. So if I have a circuit, and let me have a circuit with a voltage source and a current source, both. Okay, so we have a voltage source here. I will call it Vs. I will make it generic. I will call this is R1. I have a current source here. I will call it Is. I will have here another R2. I will have here R3, and then I will have here R4. So something like this. So in nodal analysis, the first thing you need to is to count the number of nodes. You have to know how many number of nodes we have. So here we have 1, 2, 3, and 4. So here the number of nodes is equal to 4. So this is very, very important. So this is the first thing you need to do. The second thing, we need to assign one of the nodes to be our reference. So every voltage we will calculate will be with respect to that reference. Okay, so now how to select the reference? Usually the bottom point or node is the one, or the one that is connected to the negative of the voltage source, because once we connect the negative of the voltage source to the ground, then we will know automatically the voltage of one of the nodes. So this will eliminate the number of equations. So assign one node as a reference. So will be our node here, and this is the symbol of a ground. So here the voltage is known and it's equal to 0. V is equal to 0. Number 3, assign nodal or node voltages to the n-1 nodes. Here n is equal to 4, so here we have 3 other nodes. So this is called V1, V2, and V3. Number 4, we apply KCL at each node, but we represent I in terms of nodal voltages. So we will not use I1, I2. We will not assign any current here. We only assign nodal voltages, and this is where the name comes from, nodal analysis. But so the currents here will be in terms of the nodal voltages, and how we do that, we will assume current directions, and always, as I said, to make things easier for you, assume the currents always leaving the node, except if you are given a current source, then you have no choice but to follow the direction of that current source. So if you have here resistance R, and we have here VA, and here is VB, and we assume the current in this direction, then your I will be equal to VA minus VB divided by R. So I will use this as a representation of the current, not this. Then we said one note, when we have a voltage source, we said do not apply KCL at nodes connected to voltage source. Why is that? Because we already know the voltage. So here when we come here, we said that your V1 is known to us, which is equal to Vs. So I don't need to do anything here. This is done for me. Then we will apply KCL at node 2. At node 2, we assume the currents are leaving. This one is entering. I cannot touch it. Okay. So the current to the left is V2 minus Vs, known to us, divided by R1, plus to the right V2 minus V3 divided by R2 minus Is equal to 0. So this is my first equation. We'll try to reduce this equation, try to simplify the equation so that we can easily handle it. Then also we can apply KCL at node number 3. So we look here, assume again the currents are leaving. So we don't care about the previous step. We can still assume the currents are leaving from the node. So here the current that going down, which is V3 minus 0 divided by R3 to the left, plus V3 minus V2 divided by R2 plus V3 minus Vs divided by R4 equal to 0. So we have two equations, two unknowns. The only two unknowns is V2 and V3, and then we solve them. Now, this is the first thing you do in this nodal analysis. Now, I could ask you find I, or I could ask you find anything in the circuit. You don't care at the beginning. First, you have to solve it this way. Once you know every single node voltages, then you start to look, okay, what the question is asking me to do. Okay, this I is nothing but V3 minus Vs divided by R4. And I know all the node voltages, so I can find this current. So you can find anything in the circuit, but first you have to find every single node voltages. Okay, so that's a sum of what we have covered in nodal analysis. Now let's see the second case or the third case, when we have a voltage sources connected between two nodes. And when we look here, okay, we have this is assigned to us as a ground. I will call this is V1, V2, and V3. Now this question is very interesting. Why? Because V1 is connected to a voltage source. V2 is connected to a voltage source, and V3 is connected also to a voltage source. So I cannot apply KCL to any of the nodes, which is annoying a little bit. Okay, so what should we do in this question? But wait a second. V3 is a voltage source between a node and the ground. So we said that, okay, that's I can handle. We know how to handle this. V3 is equal to the voltage between this to the ground. And we see the polarity is minus. You have to pay attention to the polarity. It is minus 15 volt. So this is my first equation. Okay, that's good. But still we have two other unknowns. Now, when we look here to V2 and V1, you can easily say, okay, wait a second. This voltage is between these two nodes. This positive polarity towards V2. So we can say that V2 minus V1 is equal to 10 volts. Basically, this is very similar to this. Actually, this one we say V3 minus 0. Here, remember, the voltage here is 0. So V3 minus 0 is equal to the voltage in between, which is the minus 15 volt. So this is with the same thing. V2 minus V1 is equal to 10 volts. So we have two equations, but still we have three unknowns. So now this comes to the concept of super node. What is a super node? A super node is a node made from more than one node. So what we will do here, I will come to this node between two nodes, actually, V1 and V2. So the super node is basically two nodes, between them voltage source. So this is the super node. So this is one node called super node. So what we'll do, I will just come and consider all of this as a one node, and I don't care about what is in between V1 and V2. It's a voltage source, I know that, but I will look to this as a big giant node. And I will care about not what happened between V1 and V2, because now in my mind, V1 and V2 becomes a bigger node, but we keep V1 and V2 as they are. They are not the same voltage, they are different voltages. And we have seen this. V2 minus V1 is equal to 10 volts, so it's not the same voltage. So I will look to the branches connected to the V1 and the V2, but not in between. So here, V1 connected to two branches. There is a third one. We'll ignore this one. The common branch between V1 and 1, we will ignore it. So I will assume a current leaving here, a current leaving there. And then V2, same thing, a current leaving here, a current leaving there, and I will not consider the one in the middle. So here we'll say KCL to supernode. And let's see how we'll do that. We'll follow exactly the same principle. There is no difference. Okay, so we will say that this current is leaving to the bottom, so it is V1 minus 0 divided by R2 plus this current leaving to the top, V1 minus V3, I will keep it as V3 for the time being, divided by R1. Now I will go to the other side of the supernode, which is at the V2, plus V2 minus 0 divided by R4, which is this current to the right, then plus V2 minus V3 divided by R3, and everything is equal to 0. So this is how we deal. So now we can substitute V3 with minus 15 volt. So we have two equations, two unknowns, V1 and V2, and we can solve them. So this is what we call the super node, and this is how we will apply KCL from that. Okay. So let's look to this question now. Here you are given the ground at this point. Okay. Now, and we have V1, V2, and V3, and we want to write down the set of equations. Now, this is not by choice, this is given to you. Okay, now if I give you the choice, maybe V1 is a better or V2 is a better way of connecting the node, and then you will not have a super node. But a super node you shouldn't have be scared of. It's just a node combined of two nodes. Okay, so here we are giving you the reference. So here your V is equal to 0. So this is my reference. This is my reference node, and I have assigned V1, V2, and V3. Okay, so we have here one of the equations that is V1 minus V2 is equal to 10 volt. So V1 minus V2 is equal to 10 volt. Then we can apply KCL at node 3, because at node 3 there is no voltage source connected there. There is only resistors. Okay, so this means that we have assumed the currents are leaving So we write the equation starting from the left. So we have here V3 minus V1 divided by R2 plus this current in the middle, V3 minus V2 divided by R3 plus V3 minus 0 divided by R4 equal to 0. So this is my second equation. Now, my third equation, we will have something like this. Consider this is as my supernode. Now, forget about what we assumed before. So KCl to the super node. So assume currents are leaving. So this has two branches, one here, one there. And this has two branches as well, one here. And this is given, I cannot touch it. So let's take this current that goes down. Let me just remove these currents to avoid any confusion here. Okay. So what we have here, the current that goes to the bottom, this is V1 minus V3 divided by R2 plus the one that goes up here, V1 minus 0 divided by R1. Finished. Finished with V1. Now what is left is with V2. The current goes down plus V2 minus V3 divided by R3. And this current is entering. I have no choice but to keep the same. So it's minus 1 equal to 0. So we have my equations, three equations, three unknowns, and then we can solve them. I will address the question of one of you guys asking me about the supernode. Is it included in the midterm? We will talk about all this at the end of the lecture. Okay, now let's have some examples here. Okay, so here we have this circuit. There's no voltage source at all. So if there is no voltage source, then I can apply KCL to any node. So this is the first thing. The second, this node is already given to me as my reference. I have this node, which is Vx to the ground. So this is Vx. And then I have this node as well. And this node is given to me as V0. So this is V0. So we have two nodes. So I need two equations to solve them. Okay. So apply KCL. I will call this is node 1 and this is node 2. So apply KCL at node number 1. So assume the currents are leaving. So this is current is leaving. This is given. I cannot touch. So the current at the bottom. So this is Vx divided by 3K plus Vx divided by 1000, which is 6K, minus 2 milliamps. Okay, so this is minus 2 times 10 to minus 3 equal to 0. Okay, so now this is interesting. This is one equation with one unknown. So I can solve for this. I can find Vx directly. I don't need to find another equation to find Vx. So here, if I multiply everything times 6K, multiply everything in the equation by 6K. So 6K times this, so this becomes 2 times Vx plus Vx. Now 6,000 times 2 times 10 to minus 3, the K will cancel with the 10 to minus 3. 2 times 6, this becomes minus 12 equal to 0. So from this we have 3 Vx equal to 12. And finally your Vx is equal to 4 volt. So this is, we found this, but we don't need this. We need this as a matter of fact. So apply KCL at node number 2. Okay. So assume currents are leaving. So this is current leaving, this is leaving, this is entering. I cannot touch it. So this becomes V0 divided by 12K plus V0 divided by also 12K minus Vx divided by 6K is equal to 0. Now I will multiply everything times 12K. So this becomes V0 plus V0 minus 2Vx equal to 0. So it means that 2V0 is equal to 2Vx, or V0 equal to Vx, which means that V0 is equal to 4 volt. Now, the question is, how do we know that this is V0? Because this point and this point and this point is the same node. There is no any component here. And we already mentioned, this is given in the question, that between this point and the ground, this is called V0 or V output. Okay, so it means that all of this is V output. The whole thing, everything is just V output. This is why we call this is V output. And when apply KCL at node number 2, the voltages here, all of them are V0. Hopefully that explains how to figure out what is V0. Okay, so now let's see this interesting question, which is a little bit more demanding. And I would say that this is the level of difficulty you would see in the exam. Okay, now let's say that we don't. I will solve this question two different ways. Okay, so I will assume, okay, let me see here. I will assume this is my ground. This is your V is equal to 0. Now in the question, if I assign you a reference point, then you have to stick to it. If I don't assign you, then it's up to you to select which one as your reference point. Okay, so this is one node, clearly. This is, I will select this as a V0. Now, this is another node, so I will call this is V1. This is another node, this is my V2, and this is my V out. So I have three equations, three, I need three equations to solve for these three unknowns. Okay, so I will call this is node 1, node 2, and node 3. You don't have to number them. You can just say apply KCL at V1. So you don't have to number them. But if this is make things more systematic to you, so be it. Okay, so here we have V2. It's very clearly V2 minus V1. So V2 minus V1 is equal to 12 volt. So that is my first trivial equation. Then I will apply KCL at my V0. So here I will assume the current here is leaving, the current here is leaving, and this current is entering, so I can't do anything about it. So we will have here V0 minus V2 divided by 1K plus V0 minus V1 divided also by 1K. So this current and this current minus or equal to, because this current is entering the node, equal to 2 times 10 of minus 3. So I will just multiply everything, but by 1K, just 1000. Multiply everything by 1K. So this becomes V0 minus V2, because the K will cancel, plus V0 minus V1, and this is equal to 2, because the 1000 times this is will just cancel this. So we will have here 2V0 minus V1 minus V2 equal to 2. So now we have our second equation. So we have now two equations, and now we want to have our third equation. Okay, so now our third equation will be our supernode. So this is your V1. So I will come here, because this is my my reference. So I will come here, cover all of this. So KCL at the supernode. So assume the currents are leaving. This current is leaving. This current is leaving. This current is leaving. And this current is leaving. Okay. So let's say, see here. So we have V1 minus V0 divided by 1K, which is the current that goes on the top here. Then the current that goes at the bottom. So it is plus V1 divided by 1K. So we are done with V1. V1 has this branch, and we ignore in the middle. Now let's go to the V2. Then we have V2 divided by 1K, the current that goes to the bottom, current goes to the right, plus V2 minus V0 divided by 1K, covered all the currents, so this is equal to 0. So let me multiply again everything with 1K. So this becomes V1 minus V0 plus V1 plus V2 plus V2 minus V0 equal to 0. Let me collect terms. So we'll have here 2V1 plus 2V2 minus 2V0, and that's it, equal to 0. Or we can say that V1 plus V2 minus V0 is equal to 0. Now let me write the other two equations we have here. We have V2 minus V1 equal to 12. So this is my first equation. And 2V0 minus V1 minus V2 is equal to 2. So we have 1, 2, 3 equations with 3 unknowns. Then we can solve them. Now, how we to do that? Okay, this is in terms of V2 and V1. This has a V0. This has a V0. So if we can eliminate V0 here, then we have two equations with two unknowns. So from this, we can say that V0 is equal to V1 plus V2. Okay. And then we can come here and we can substitute. So we can substitute V0 in this equation. So we will have 2 times V1 plus V2 minus V1 minus V2 is equal to 2. So this will lead us to have V1 plus V2 is equal to 2. So now I have this equation and I will have this equation. So if I add these two equations together, let me add this plus this. So let me call this is the equation number 1, and this is equation number 4. So add 1 and 4. So we have V2, this becomes 2V2 minus V1 plus V1. We'll get rid of V1, and this is equal to 12 plus 2, which is 14. So from this, your V2 is equal to 7 volt. Your V1 is equal to, from equation 1, is equal to V2 minus 12. So it's equal to V2, which is 7 volt, minus 12 equal to minus 5 volt. And finally, your V0 is nothing but V1 plus V2, which is equal to the V1, which is minus 5, plus V2, which is 7, and this is equal to 2 volt. Let me see your concerns, questions here, and let's see if we can here. So whenever we have a voltage source, we'll have a supernode. No. If we have a voltage source between a node and the ground, there is no supernode. So this node will have the value of the voltage. The supernode, when we have a voltage source between 2 points and none of them is a ground. So hopefully that's explained. Is there a strategy? Okay. Now the if I don't give you the reference point, then maybe the best thing is to apply it to the negative of the voltage source. And let me demonstrate this. So let me come here and resolve this question. Let me first clean everything here. Let me clean everything. And now let me select the negative of the voltage source to be the reference point. So this is equal to V equal to 0. And now this is not the reference, so this is my V3. Okay. And let me call this is V1. And this is my V2 or V output. So what I did here, instead of having my reference here, it becomes here at the negative of the supply. So this is, I think, a better strategy. Why? Let's see. Now, V1 is equal to 12 volt directly. V1 is the voltage between this point to the ground. So this is equal to 12 volt. Done. Now I have two other nodes. I have KCL here and KCL at V out. So apply KCL at V out. So assume the currents are leaving and this current is entering. I cannot touch. So it becomes V0 minus 12 because this is to the left. This is V1 and we know it's 12. So V0 minus 12 divided by 1K plus V0 minus 0 over 1K. So it's V0 over 1K. And this current enters. So this is equal to 2 milliamp. So let me again multiply times 1K. So this becomes V0 minus 12 minus V0 equal to 2. And from this, your V0 to V0 equal to 14. Then your V0 is equal to 7 volt. Wait a minute here. And this is a question for a bonus. We found in the previous question that V0 was equal to 2 volt. And now here the answer looks very nice, very simple. But V0 now is equal to 7 volt. So what's going on here? Can someone answer this question? Okay, okay, excellent. I like that, guys. Okay, very good. So let's see who deserves the bonus question. Your reference is a different place. Okay, it's all relative. William Najib Mazhar, I think you deserve the bonus mark. Your reference is in a different place. It's all relative. Excellent answer, William. Please send me your ID to give you the bonus mark. Yes, because everything is relative. Now, in the previous time, we have this assigned as a 0. And remember, the voltage is always between 2 points. The voltage is always between 2 points. So it's between this point and this point. Always the voltage between 2 points. So that was 0. Then this is why it was 2 volt. Now, V3 still is unknown to me. So we need first to find V3 and then V out becomes, let me, to be even more realistic, let me call this is V2 actually. This is not V out. This is not V out. So this is V2. So this is KCL at V2. This is V2, 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 and V2 is equal to 7. Actually, V2 is equal to 7, not V out. V out, basically your V out is V2 minus V3. This is your V out. In the previous example, it was V2 minus 0. This is why we assume V out is equal to the same nodal voltages. So we need to apply KCL at V3. So assume all the currents are leaving, and this current is leaving by default as well. So we have V3 minus 0 divided by 1K plus V3 minus V1, which is a 12 divided by 1K, plus this current is nothing but 2 times 10 to minus 3 equal to 0. Multiply everything by 1K. So this becomes V3 plus V3 minus 12 plus 2 equal to 0. So 2V3 minus 10 equal to 0, or V3 is equal to 5. V2 is equal to 7, so your V0 is equal to 7 minus 5, which is equal to 2 volt. So we get the same answer. And you can see here the math is relatively easier when you select the reference as such. So it's either I give you a reference or I don't. If you give you a reference, you have to stick to it. If I don't give you a reference, then it's up to you to select which reference is more convenient to you. Okay. Now let's go to the real deal and let's go to the midterm. Okay, so there's no other question. So let's go to the midterm. So the midterm, we will have the following number of questions. Okay, the first we'll have one question, nodal analysis. This will be 20 marks out of 100, and you would have either supernode, you could have a supernode, or you could have dependent source. So it's either this or that's. It's random. So it depends which one you will get. It's either supernode or a dependent source. Then the second question is KCL, KVL, and this is also 20 marks. Dependent source is the previous example. The dependent source, when we just have it in the previous example. Number 3, you will have circuit or R reduction. So we give you a mesh of resistors, and this is 15 marks. Number 4, voltage, current, division, also 15 marks. So far we have 70. Number 5, you have a Wheatstone bridge with strain gauges. This is why when you have a beam, you apply a force to it, any type of force, then find the voltage. So that's typical, and you have all the cases 1, 2, and 4 strain gauges. And this is worth 20 marks. Last but not least, you will have 10 multiple choice questions, and this will become from week 1 and week 4, and maybe very, very, very simple circuits, like one loop or something. This is very, very trivial circuits. Okay, so this 10 multiple choice, each one is 1 mark, so this will becomes 10 marks. So you'll have 100%. So this will be your midterm. The number of the time for this will be, as I said, open. The window will be open for 24 hours, but the exam will be 2 hours and a half plus 1/2 hour to upload, to scan, to do everything. So your total time is 3 hours. You don't need half an hour to do that, to upload stuff. So mostly you need like 5-10 minutes at maximum. So 3 hours will be total number, the total time for your exam. Okay, now let me see if you have any concern about the midterm. SG means string gauges. This is a string gauge. Will we get practice materials for the midterm? Yes. The date is as per in the syllabus. It is 21st of June. So Monday. A reduction when you have a mesh of resistors and you add resistors in parallel and in series. Okay, now that's a good question. The questions will be on Learn. You have to go there. You have to enter the numbers, but we will not mark this except for the multiple choice questions. In the multiple choice questions, there you don't need to submit anything. But the other 5 questions, you have to fully write the answers, and then there will be you'll go to Dropbox in your Learn, and you will upload your file. So you have to upload your file, and that is the file that will be marked. But in that file, you need only to have the 5 questions. The question number 6 will be already, the mark will be given. But also for the other questions, there will be a space to enter the number. But don't worry about this, and we will hide from you the if it's right or wrong, so you will not be disturbed at all when you submit your answer. So don't worry about that at all. We will not mark those. We will mark the full answer that you will submit in a Dropbox in Learn. And I will be sending to you detailed email about every single thing I have talked about. Yes, you can print the midterm, of course, and you can write and then scan this. You can do this. That's okay. Okay, but remember the questions. The exam will not be PDF. The exam will you go to Learn as a quiz, and you will see the questions in front of you. If you want to take this, print it or save the figure to write on this, it's up to you. But you can just draw the circle. This is more practical than printing these ones. It's not crowd mark. We will not use crowd mark for the midterm. It will, everything is Learn. You will go to the, I will tell you exactly, you'll go to the quiz and Learn, you go enter the exam, you enter the answer, you submit your answers, and once you submit your answers, it will be locked there, and we know that you were there. You have to submit, and then you go, after you finish everything, you scan your answers and you submit them on there. How long would you say the midterm should take to write? I think it should not be more than 2 hours. It's like almost 1 hour extra for you guys. You want us to use a circuit editor for the exam to create no, 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 please, no fancy circuit, just be to the point. I don't care. Don't waste your time on these things. Okay, just draw it by your hand. That should be fine. Okay, so I will stop the recording now. No, please, the files has to be PDF. Do not have photos. So you have to upload only one file as a PDF file. How to do it is up to you. You scan, you print, you convert PDF directly. This is up to you, but you will submit only one file in PDF format.